In this video, I'm going to talk about half-life. So the first part, I'm going to talk about the references, talk about some features, and then the second part, we'll be talking about the half-life worksheet, part A, part B, and part C. And then D, E, F, and G will be another video. So half-life, the definition of half-life is the time required for half the sample of the radioactive substance to disintegrate, meaning like they're getting smaller and smaller by either radioactive decay, for example, like C14, or natural processes, for example, like bacteria, okay? So in this worksheet, we're going to talk about using radioactive isotope because they have different half-lives for each isotope, so we can decide the age. Now, there are three purposes of using half-life that I can introduce you. The first one is the C14. The carbon-14, we can use it to find out the age of an object. For example, we can find the age of the like a piece of art, or the age of the tree. And then the second purpose is we can use iodine-131 to see if someone has thyroid disease, diagnosis thyroid disease. And third one is we can use cobalt-60 to destroy cancer cells. Now, I have 5 symbols here. Each they have different characteristics. So the N will be the number of half-life, how many half-life, like 1 half-life, 2 half-life, 3 half-life, kind of like generation. So they must be whole number. And the question we usually ask you, how many half-lives? The second number is T-half. T-half is also half-life, but this half-life is not number of half-life. This half-life is the time. How long would that take for like 100 gram of sample to decay into 50 gram, half of it. So how much time? So this time can be any number, like decimal places with any unit in the time. And usually the question will ask you, what is half-life? And then the T total is how much total time it eclipsed, or like the age, and usually any time. And it could be like the question will either ask you like how, like the total time, how old, or how long, okay? And then A0 will be the amount at the time 0, meaning the original amount. Because we're doing decay, the sample will getting smaller, 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 smaller in amount. So then the original amount must be a big number, okay? And then usually they will ask you like, what's the original amount? And finally will be AT, is the amount left over or remaining at the time, whatever the time is. So since the decay happened, the amount will get smaller, smaller, smaller. So how much remaining will be a smaller number, and they will usually ask you, will remain or will left over? Now, the first thing I want to introduce is the formula. Now, I usually have like number of half-life equal total time over the half-life, but I usually like to use like triangle to remember all 3 equations instead of just one here. So I'm using the triangle here, T total on the top, T half on the left, and the N on the right-hand side. This part will already introduce 3 different equations. This is one of them. And then for this 3 on the bottom, we're going to introduce another video. So I'm going to talk about the worksheet A is the decide the half-life, which is T-half. So we want to label the numbers. If 100 gram of carbon-14 decays will decays until only 25 grams is left after this amount of years, what is the half-life of carbon-14? We want to label what the numbers are. So 100 gram will be A0. Carbon-14 does not mean anything, forget it. 25 grams is left, will be AT. And then after this amount of years, this will be my T total. And what is the half-life, right? What is the half-life? If you look up here, what is half-life? They actually asking you T-half. Okay, so what is half-life? They actually ask you T-half is a question mark. Okay, so we want to list it out on the left-hand side. A0 is 100.0 gram. AT is 25.0 gram. And T total is 11460 year, and T-half equal question mark. Now, we usually, in a question like this, we usually have 5 stuff. even though the T half is the question mark, but we also list it out. So actually we're missing what? We're missing the n. Now 99% of the questions will ask you, you have to find the n. Okay, so you see that I actually separate the question into two parts. Okay, so all the question you want to split like that way. Okay, we split like that way. So we want to find out how many half-life first. How many half-life, right? How many half-life is actually n. So we're looking for the n first. So how do we do it? We start with A0, 100.0 gram. Because it's a half-life decay, we take this divided by 2 to get 50.0 gram. So here is one half-life. But we are not done yet because we need to get to 25. So we continue to divide by 2 to get 25.0. Now we can stop because we reached the 80. Okay, so here we got 2 generations. So that's why my n is 2 half-lives. Okay, now you want to solve for half-life. Solve for half-life meaning we're looking for t half. So if you go back to the triangle, okay, we do have t time, t total in the question. We have n. So how do I find a t half? T half is tt over n. So we always write down the formula first because in this packet we have different formula. Okay, so we start with equation, the formula, t half equals tt over n. We start with this. We're using the triangle. We put in the numbers. T total is 11460 year over my n is 2. And I should get 5730. But on this worksheet, I want all the numbers to decimal places. I want all my numbers to decimal places. So I have to continue to give 2 decimal places. 5730.00, and my unit is year because this is coming from here. Okay, I'm going to do one more. What's the half-life? Okay, so that means I'm looking for T half equal question mark. 100 gram of sample, nitrogen 16 decay to 12 gram in 28.95 seconds. So my 100 gram is actually AO, and nitrogen 16 can ignore that. Decay to 12.5 gram, which is AT, and then the 28.95 seconds is T total. Okay, read the sum out, put it on here. A0 is 100.0 gram, my AT is 12.5 gram, my T total is 28.95 seconds, and my T half equals question mark. So again, we split into part A and part B because all the time we want to find the n. Okay, so we want to find the n. So my n, we got to start with the 100.0 gram. Start with the A0. We don't need to put the unit. Just 100.0 divided by 2. So 100.0 divided by 2, and I will get 50.00. So it's 1 half-life, and we need to continue to divide by 2 to get 25.0. This is my second half-life, and we need to continue to divide by 2 to get my 12.5 gram third half-life because I need to get 12.5. So I pass 1, 2, 3. So that means my n is 3 half-life. Right? That's part A. Now I'm looking for T half. So again, we use a triangle formula. We write down the formula first. So T half is T total over n. So we put 28.95 seconds divided by 3. I should get 9.65. Now this 9.65 is coming from the calculator. We need to do rounding. So we need to think about rounding again. We write this again. 9.65 seconds. So that is the A one. We gotta do the B part. The B part is determine the total time elapsed, T total. Okay? So how are you gonna do that? We look up the question. The half-life of a radioactive sample is 25.89 seconds. Okay, so this 25.89 seconds is not the T total is half-life. So we label this is half-life. How long? Okay, how long? It means that I'm looking for T total. Right? It takes 560 gram sample to decay to 1/4 mass. So 560 is A0. Now 1/4 the mass is AT. But there's a problem here because I did not give you the actual gram of AT, but we can deduce that, but you need to show math, okay? You cannot just start with a number which is not given in the question. So we list it out. A0 is 560 gram. Now how do we figure out the AT? My AT is 1/4 of the 560. So we take 560 multiplied by 1/4 and I will get 140 gram. And then my T half is 28.95 second. And then T total equal question mark. So again, these 5 things, the only thing I miss is the half-life, okay, the N number. Okay, so we find the N. So again, we start with A0. Okay, so we start with A0, so we take 560 divided by 2 to get 280, that's 1, divided by 2 to get 140, that's 2. So we reach 140. So that's why my N is 2 half-life. Now this time I'm looking for my T total. So if you look back the triangle, the T total, the formula, T total equals T half times N. We write down the formula because we have so many formula. So T total equals T half times N, which is 28.95 second times 2 equals 51.78. Okay, this is the calculator. Now you need to think about rounding. Okay, it's already 2 places. We write this again, 51.78 seconds. Okay, because this is second, this must be second. Now, what does this number mean to me? Now, you don't have to write this sentence in all the question here. I just need to write once on here. But on the activator, on the test, I will ask you to write the sentence. What does this answer mean? This answer means it takes 51.78 seconds for 500 gram sample to decay to 140 gram. So it takes 51.78 seconds for 560 gram sample to decay to 140 gram. So this number is actually the total time elapsed, T total. Okay. Now if we go to the C part, we will find out something. Now the C part is also find the T total, but this time we're talking about the age of an artifact or like the sample. But so that you can tell B and C, the math is the same, but the concept is different because B is talking about how much time it takes, and here is the age or how old. Right? Now the half-life carbon-14 is 5715.2 seconds, so this is my T half. How old? What does that mean? How old meaning looking for T total. And we start with 16 gram, which is A0, and we end up with 2 gram, which is AT. Okay, so we list it out. A0 is 16 gram, AT is 2 gram, T half is 5715.2 year, and T total equals question mark. Okay, so we first find the N, right? My N, again, we do the same thing, 16 divided by 2 to get A, 1 divided by 2 to get 4, 2 divided by 2 to get 2, which is 3. We need to get to the AT, which is 2. So we stop here, and so then my N is 3 half-lives. Okay, because we want to have 2 grams left over, so we pass 3 generations, so we have 3 half-life. And then T total the formula is T total equals T half times N, which is 5715.2 year times 3 equals 17145.6. Okay, now again I want two decimal places. So 17145.60 year. Okay, now what does this number represent? This number represents the age or how old. Okay, so we're gonna write the ancient sample is 17145.60 years old, okay, or is talking about the age. Okay, so the Asian sample is 17145.60 years old, or you're talking about the age.